Thanks, everyone. Thanks. Welcome to our session from paper to practice. So implementing NIST cloud security guidance. Anybody who's here, I guess, either wants a way to get to sleep or has to implement some NIST cloud security guidance. But no, hopefully this session will be a bit of a theoretical overview for folks who haven't dived into the sort of recent specs, and then some more practical advice. It was originally structured as a talk, so we do have a fair amount of exposition discourse on some slides. This stuff's kind of like lost. You had to sort of be there from the start for it to make any sense. So we go through some of it, but I will obviously skip a lot of that because this has turned into a fireside chat with my esteemed colleague and friend Andrew Martin, who has a more practical experience, obviously running a security consulting firm of actually helping folks through this kind of stuff. So hopefully we can have a bit of insight from the other side of things as well. Cool. So, a bit of jargon out of the way. NIST, for anybody who's not come across it, is the National Institutes of Standard and Technology. It's a US federal government body that does standards around weights and measures and everything from that to cybersecurity. It's very smart people. We'll hear SP quite a lot. That's special publications. So these are the main body of documents that NIST produces. They are standards and guidance for all kinds of things. For example, SP 500-158 talks about accuracy, integrity, and security in computerized vote tallying. It's from 1988, and it's a bunch of standards around electoral voting machines, right? Automated, like those punch card voting machines. Very relevant then, very relevant now, still the subject of some lawsuits. So that's the kind of stuff that they get involved with, but the SP 800 series focuses on information security. If you ever do want to go read one, I mean, they're pretty long, but they have a fairly typical structure. They're fairly stamped out. They're kind of backloaded. You probably want to start at section 3 or section 4 for the good bits. They can use quite academic language in certain places. They'll talk about things like security kernels and reference monitors. These are academic terms from like 1972. But you can Google them, and other than that, the recent ones are actually quite well written and quite accessible. I guess it's worth saying these things are guidelines and standards. They're kind of a consolidation of known best practices. They don't try to say anything that hasn't been said before. These are what some people are doing, your Googles of the world, and what everybody should be doing. But it's not new research. This isn't a thesis. It doesn't try to prove what it's saying. So, diving straight in, SP 853 was entitled Recommended Security Controls for Federal Information Systems. This was back from 2005. The authors were a bunch of people at NIST. I'm one guy from some private logistics supplier to the US government. And this is like the granddaddy of these information security standards. Loads of people still reference 853 because it's actually got a load of technical controls in it. It's not really an organization policy doc. It doesn't talk about documentation standards. So it's referenced, or it's the baseline actually for a bunch of other standards in the sort of banking sector and whatever. The closest equivalent might be the appendices of ISO 27001 kind of thing. It does contain some process stuff, but as I say, there's a lot of technical controls in there. So for example, we have the famous Security Control 8 and Security Control 9, which are the ones about integrity and confidentiality of data. So this is confidentiality, SC8 is integrity. If you use encryption, they're two sides of the same coin, but you can achieve them separately. So this thing will say, we have a control that says something like the information system protects the confidentiality of the transmitted information. There's a little bit more guidance about where you can go and read stuff. And you notice that there's 3 levels of compliance, of control that they talk about, low, moderate, and high. And this control, like many of the others, is different depending on which one you're going for. So, low, don't bother with information confidentiality. This was 2005. Moderate, yeah, you've got to do something about it. And high, yes, and that something's got to be encryption. So getting into the implementation, spoiler alert, we might want to encrypt our data in transit. For that, you might want a service mesh, for example. But more seriously, a service mesh can hit a lot of the controls in 853 and the later ones that we're going to see. And that, I guess, is why the guy from the service mesh company is the one who knows about it and is talking about it. For example, there's another thing that says you have to control egress. So if you're using a service mesh, then you can do that fairly easily. You can do defense in depth. There's a whole load of strategies we can apply that map quite neatly. So that was, as I say, 2005. The thing's been updated, so as recently as 2020, we got to essentially version 5.1, revision 5, update 1. It's been revised so much along the way, it got a new title. It's now just attributed to the Joint Task Force, which basically means everybody's had a go at it. But what's interesting about the latest version is that FedRAMP is in these documents as well. So for anybody who's not familiar, FedRAMP is a set of standards, a set of things you have to do to your systems to prove you're secure enough if you want to supply the US government agencies, right? And that's not just three-letter agencies, that's any part of the US government. So if you want to be a supplier to them, interact with them, run on GovCloud, you've got to be either FedRAMP low, moderate, or high. So the FedRAMP specifications basically select a subset of these different controls from 853 Rev 5. So remember how that control we saw earlier, had different interpretations for those different levels. FedRAMP is like that, so FedRAMP low will select some of them. What's a little more difficult is, as I say, each of those controls is different. So there's different implementation guidance for each control at each different FedRAMP level. So if you're FedRAMP moderate and you want to go to high, you're not just adding extra controls that you didn't have before, you have to reinterpret all the ones you've already got. So that can be quite time consuming. I'll skip through this, but it's kind of fun. It got a lot more complicated, right? So this is just the first part of SC8 now. It's got a bunch of sections in it. It has added some more clarity and detail. For example, it says that all data in transit between OS processes must be encrypted, so down to that level. But there's this other random document, which is ostensibly about vulnerability scanning, but it contains this lovely section 4.0 that says, just to clarify, when FedRAMP talks about encryption, that includes, when 853 Security Control 8 talks about encryption, it does mean from an application container to a sidecar, for example, if you're in a cluster. Now notice it says usually encryption. So this is SC8 subsection 5, and this talks about the fact that instead of encryption, you can use a protected distribution system, which is basically where if your data stays within what they call a controlled access area, like a super secure data center where people can't just walk in and start tapping wires, then that's good enough as well. So that would be something like a cloud availability zone. But there are, I shit thee not, Word documents that contain appendices to this. So these specs are, if you're going to go out and actually try to learn all this stuff yourself, the specs aren't the be-all and end-all. There's clarifications and details elsewhere. So there's this Word doc, which claims to be an appendix, and actually clarifies that previous statement and says, right, when we're saying data in transit, which remember is between any two OS processes, including app to a sidecar, we can achieve the confidentiality with either encryption or physical means, right, or keeping it in one of those CAAs. And then there is a blog that comes along, again, very helpful, data in transit, which is guaranteed to stay within a single confidentiality access area, right, a physical data center, then SC8.5, so physical protection is sufficient, you don't actually need encryption. So that whole thing about app to sidecar needs to be protected, but it can be physically protected because it's within one pod, right, so it's going to be on one host, so it's definitely physically going to be in one building. But do remember that not all availability zones are one data center. Sometimes they're two data centers next door, and you might have to go look at AWS artifacts to find out whether your availability zone is one building or two. Because although, when this applies between an app and a sidecar, we know it's in one net namespace, we know it's in one kernel, we know it's definitely on one machine, you've got to satisfy the auditor that you meet these requirements. And these documents don't talk about that at all. The auditors may not understand that. Actually, all you have to do to satisfy the auditor is to say, well, it's definitely within one building. And they're like, okay, cool. Even though we can actually quite easily prove something a lot more strict, a much better security property. Anyway, I'm going to stop waffling there, and I'm going to start asking questions of the panel.
Uh-oh.
I mean, things are complicated, right? 53 is that we'll come into some of the more modern ones around microservices and Kubernetes and stuff specifically, but 53 is still definitely writ very large. It's complicated. What is your experience of helping folks implement a sensible set of controls in 2025? Do they look at 853? What do they look at? Do they bother?
Yeah, 53 is still very much the guiding, defining light. We have done some work, for example, with iSurveillance for how Cilium and Tetragon comply to those requirements. So things like, what is your encryption in transit? How is your data access logged? You raised a point from a different standard about the sidecar reverse proxy encryption. That's a debate we've been having for about 8 years, whether Istio is actually secure to have unencrypted traffic in the same network namespace. The principle being, of course, is that if a network namespace is untrusted, then the container security model is fundamentally broken. So that dissonance leads to a wider point, which is really a lot of the value that we provide when we do those integration pieces with customers is auditor facing. Auditors tend to come from perhaps a more fiscal or accountancy-based background. They're less likely to be technologists, and as a result, giving them what they need to gain the confidence that your solution conforms to a set of requirements that they have no technical basis or desire to decompose into something that they understand, and instead suitably offsets the risk and fundamentally manages the liability of not having conformed correctly, tends to be where we handhold, cotton wool glove, padded cell our way through that audit process. But really, there is nothing better at this point. While some of the rules are very much, or some of the guidelines are very much open to interpretation, they cover everything that we would expect and do so in a thoroughly comprehensive way.
Cool. Yeah, I mean, that's why I brought SC8 up specifically as an example. I mean, not only is as funny as stuff about NIST standards is probably ever going to get, it's also one that is widely open for interpretation. It was very broad, and then it was brought in by a newer version of the spec, but then there was a Word doc here and a blog there that maybe said things that contradicted each other, and it's something, when we talk about implementation, I said we discussed the theory and then implementations of it. Yes, a lot of the implementation is technical. You could get a service mesh, configure it like this. You get a GitOps, CD system and configure it like that. Your ultimate outcome, actually, your ultimate business value from this, is getting signed off by the auditor, right? Of course, we want our systems to be secure. Of course, we want to protect our users, but you have to get signed off by the auditor as well, right? So I think that's the nuance to a lot of it.
You hit the nail on the head, because really, it's this eternal question of perfect security that inhibits innovation and feature delivery means that your competitor, who is either not constrained by the same regulation or has found a faster way to compliance, whatever that would be, will essentially win the market race. Yeah. And so security really means nothing if the business has existential threat from absence of funding and shuts down. So it's a fascinating balance to walk, and you see obviously VC-backed companies early stage accelerating fast and then backporting security, and you see enterprises trying to move quickly but being constrained by existing departments of the bureaucratic red tape interior. And so somewhere in the middle is the sweet spots. This is why skunk works can often be so effective in large organizations. But yeah, of course, it is just, can you actually ship that feature irrespective of how secure it's perceived to be, without doing something catastrophic and terminal to the project?
And that is, to be fair, why we wanted to talk about the NIST standards, because they are actually not bad, right? They're not the kind of thing where you sort of roll your eyes and you're like, right, let's get a tick. They don't talk about the format of your documents. I just don't like 9001, sorry. But they do actually, if you're going to pick anything as a base, if you just want to get better at security and you want to go read the work of some people who've really thought about it, this is probably one of the better things to go read, I would say. Cool. Let's dive on very quickly. So there, you might have a document like 853. The Americans in their different language would call that 800-53 naked, because there'll be something like a 53A, a 53B. So sort of 50. We talk about 53 original, 53 no letter, right? The system is like base -1, and it's confusing. But so there's also, for example, a 53A, which talks about how you might audit these kind of systems. There's a 53B that talks about what the baselines to the controls might be. So these are sort of taking subsets of those. These are more practical guides for taking subsets of those controls and doing sensible things with them. So you do tend to get these. They're not appendices, because the specs themselves are already hundreds of pages long and already have lots of appendices with subsections in, but you get these supplementary documents that can talk about slightly more practical things. Maybe I'll probably skip this. Well, this is meant to be a more technical example, right? There's another control in 53, actually AC4, we're talking about access control rather than straight up security, which basically, it's very bureaucratic language, but it basically says you need some access control between systems, you need some kind of ACL, right? Some kind of, service-to-service RBAC. So the point of this section is to say, in some things there is a fully technical solution. You might take a service mesh like Istio. This can fully hit this requirement for the access control because it can do strong auth using X509 certs. You actually get the encryption in transit as a byproduct almost because you're using X509 certs. You can do a mutual TLS handshake and you can hit SC8 as well. But you get auth N, so identity using X509 certs. And then if you can trust those identities, you can do Auth-C, and Istio and Envoy have support for RBAC-based access control lists. You can also control ingress traffic and you can control egress traffic. So AC4 is the kind of thing you can fully hit with a tech tool which is configured properly. And you might go write even down to some YAML like this, which turns on strict MTLS and says, right, we need that encryption in transit, we need that strong auth everywhere. Something like AC6 says, well, you should have the principle of least privilege, right? Which is great, but a technical tool for like a service mesh can sort of partially hit this. The fact that I can do fine-grained auth, right? This isn't Windows 95. I'm not either logged in or not. I can actually have some kind of differentiated access control between different roles. I can assume privileges and drop privileges. Like that's great for the sort of runtime part of least privilege because I can always act with the least amount of privilege that I need. But you probably also want to be doing human audits, right? You also probably want least privilege reviews every 3 months where one human sits down and looks at the list of all the other humans and says, oh, does Dave still need that access? He's moved to a different department internally. So I guess this is just an example of where it can't always be, although it may sound like a technical control. It can't always, you can't always just buy a tool that's going to go do it. I wanted to quickly move into OSCAL, probably ask you a little bit about this because it's very exciting. I won't spend too long on the slides, but OSCAL is actually, I'm just going to hand this over to you. Do you want to explain OSCAL, continuous compliance?
Well,
do you like it? Do you hate it?
Being unable to remember the initialism, I'm glad that we can agree it's the Open Security Controls Assessment language. Thank you. OSCAL moves us in a direction. If we take DevOps if we take development to DevOps, then we move from point and click or pray and spray with operations into declarative configuration, into resolving a state, and into actually writing tests and building out things that are development-like in operations. OSCAL is on that DevSecOps continuum, but not for application security, for infrastructure security. So it uses essentially human-readable language to define this is what your control suite should look like if it was to be executed by a machine. Now, it doesn't have an extension. Well, it does have an extension. It doesn't have a core functionality to allow it to run automated tests, which is 50-50 because on the one hand, it is Gherkin-like, so kind of behave specification language, which requires, it's not as granular as large-scale testing probably should be, so you end up with potentially inefficient test suites that do the same thing every single suite, and it's less optimized operating at scale. But then Lula, a tool from Defense Unicorns and Brant Keller in particular, who works in the CNCF's Tag Security Technical Advisory Group and is a highly productive and intellectual engineer, has extended OSCAL so you can run those automated tests against the definition of the specification. This is next generation. We thought we were going to wait 100 years for this to turn up in compliance environments. In some ways, this is akin to getting a SOC 2 certification with screenshots and give or take a browser console HTML edit to get a screenshot compliant. There's no chain of custody for that control. These things happen in organizations. The screenshot is taken as sacrosanct and legal evidence of compliance. I mean, there's no validation on that. The auditor, again, is just signing off. So moving from that phase with SOC 2, for example, or similar ISOs where screenshots are taken as evidence into read-only programmatic APIs where we can pull configuration information, run continuous assurance against those systems And actually, some of our stakeholders have been going a combination of bananas and hell for leather with the hyperscalers for the last 3 or 4 years. And we're slowly starting to see this, where you click one button and the cloud provider runs a set of compliance tests, static analysis against your configuration to tell you if you're currently within compliance for whatever standard you want. These are still nascent. It's probably another couple of years before they're really where they need to be. But this whole concept of automating security and compliance is finally, again, that sort of glacial, incredibly slow rate of change for anything security related because of the potential side effects. We're now starting to see the embracing of those DevOps practices in the same way we went from dev to DevOps. Now DevOps to DevSecOps is an order of magnitude slower, but it's moving, and really very exciting to see.
Cool. No, that's an awesome overview. Yeah, so this idea of continuous compliance. I mean, these OSCAL is meant to be this machine-readable format for codifying these controls, right? And therefore being able to execute assurances of them automatically. It's, again, pretty broad, maybe not so well defined. A lot of OSCAL documents you see actually contain inline rego. But, you may have some rego that matches this and says, right, pull the configuration from my cluster and check that strict mutual TLS is turned on. That's a very, very simple example. This stuff gets into 1,000-line YAMLs, like, very quickly. But, yeah, that's an example. And you can have this, imagine, in a Kubernetes operator or something that's evaluating it every second, or just has a watch, right, and is evaluating every time these resources change. Speeding up a little bit to some of the newer, more cloud-native-y kind of specs. So there's 800.204 series. 204 naked is security strategies for microservice applications. 2019, written by a NIST researcher who goes by Muli. Muli is awesome, super smart, very academic, kind of intellectual kind of guy. But this is a very good standard. It's kind of a high-level overview of microservice security. It talks about how you trade security to resiliency, which, to Andy's point, if you're too secure, you can't get anything done. You're not resilient to anything. And it talks about how things like retries and circuit breakers give you resiliency, but they can also be a security kind of control. This is maybe for some kernel to read who doesn't know what a VM, the other kind of kernel, I should have said, model of a modern major general who doesn't know what a VM is, right, and kind of needs to get up to speed. Telling him that warfare is not only kinetic now, like cyber is a thing that's happening. But no, so the jokes aside, it says a strategy for resiliency is client-side service discovery, but it doesn't tell you how to do that. It will say things at a high level like, well, you need this runtime service discovery system. It should be highly available. It should be secure. It should be done at the client side. It's kind of meant to be a level set. For if you're not here already, you should probably go sweep the ransomware out of your system. But this is where everybody should be, and then we can take it on from there. So 204A, which was Muli and actually my colleague Zach at Tetrate, talks about building secure microservice-based applications, specifically using a service mesh, because as I say, it's only one tool in the box, but it is a service mesh is a tool that can tick a lot of these boxes. And it basically says, go look at 204, 204 original. It gives you a lot of strategies. A service mesh is a good way to hit a lot of them. It doesn't mention vendors, but it says pick a mesh that has the following features. It must got to be able to intercept traffic, do that fine-grained access control back from 53, and all those kind of stuff. So let's talk about picking one with the right set of features, configuring it in a secure way, and then that's a good basis for actual secure microservice deployments. And then 204B is even more practical and introduces sort of the word zero trust and talks about doing zero trust at runtime. It talks about access control. It talks about ABAC and RBAC, and it's sort of much more practical on those side of things. It also talks about sort of Kubernetes because it does assume you're using a service mesh. It does assume you're in Kubernetes. So it talks about kube security best practices as well, like getting that baseline there, because all this stuff has to build and everything else. Andrew Martin, you've seen a few Kubernetes clusters in your time. Have there been any fun? Are we still talking about kube security? Because I know they've been through some iterations. They threw security policy away, right? And we're on V2 of a lot of this stuff. Have there been any fun changes recently? Are there any exploits still?
Yes, I mean, some of the original design decisions, I got into trouble back in the day for saying Kubernetes is not secure by default. Now, I'm not saying it's insecure by default, but by extrapolation. And the reason for that is that Kubernetes was built to bootstrap developer experience and some operational stuff as quickly as possible. It won the orchestrator wars, I guess. We had Docker Swarm at the time, we had Mesos, Marathon, we had all of those things, and they kind of tried to converge and eventually just were subsumed in their entirety. Amazon was trying not to ship EKS for many years, but then even they had to succumb to the motion. That optimization for Bootstrap meant no network policy by default. It meant no pod security configuration by default. It meant you spun up out of the box with a read-only port that gave you access to all of the environment variables and containers, which the Heroku 12-factor app methodology or paradigm suggested was the way to mount your secrets into an application. So huge dissonance, wins the orchestrator wars because it's easy to use, quick to bootstrap, massive adoption. It's easy for organizations to take experience from a different company and just bring the engineers in because you're not reorchestrating, Twitter's Marathon compared to LinkedIn's, enterprise service bus style. All that being said, huge strides have been taken. So now, we have pod security standards out of the box. The read-only port's been shut down on GKE finally, I believe, recently-ish. And the number of easily accessible foot guns has been reduced. Now, obviously, we have a penetration testing team, and Kubernetes and containers is our speciality. We reported what we consider a critical bug, let's say, whereby a user is able to relabel their own namespace to remove pod security standards from within, and it was reported as do not fix or will not fix as designed. So we're still in the case where the system is designed with the operational concerns for distributed system teams in mind and not for what's the easiest way we can make this thing secure. Now, on the flip side, it generates work for us as individuals and in our organizations, but really it's frustrating to see that decisions are still being made based on maybe in some cases intellectual purity or system design, and not very simply cloud misconfiguration is the greatest form or the greatest route to breach. How do we do secure by design, secure by default? These have been ingrained in US executive orders, which is deeply enlightened, and I never thought I'd see in a month of Mondays, let alone my lifetime. But yes, so there are still, unfortunately, emergent misconfigurations from multiple clusters. There are some foundational new features, especially around pod security standards, that have not hit the secure by default mark that they really should have done. And of course, the emergent complexity of attempting to run nested self-service namespaces in a wider system, because multi-tenancy and bin packing saves us money. When we've got 400 node clusters, well, nodes are not namespaced. Fundamentally, they weren't included in the namespacing model. We can node pool, but there's no hard security barrier on nodes. So there are still fundamental questions about how the system is designed, and this is where things like GKE Autopilot and the equivalent from EKS and AKS help to provide some value, because if we can just deal with right-sizing the workloads and the underlying hardware, and the rent of the control plane computes is very cheap, then we can do per cluster segregation, and that's the hardest boundary that we can get. Multi-tenancy on a single cluster still has enough foot guns for us to make money pen testing it, I guess.
Yeah, cool. Yeah, because obviously this stuff specifically gets into more implementation details, talks about service meshes. As I say, 204A talks about what you've got to configure the mesh right first before 204B comes along and tells you how to secure your apps using that mesh. But it is, to coin a phrase, turtles all the way down, right? And so your kube has to be right, your cloud has to be right, and misconfiguration at all of those levels is super easy.
And you raised IAM as well. Of course, the socio-technical human element is the weakest link.
Yeah, as ever. Just to speed through these. I mean, these are all very useful. 204C, another Mooney one, talks about CI/CD. Again, very useful, very practical. If I've got 5 seconds, it basically says GitOps is good. I don't think anybody would disagree with that. Obviously, there's ways and means and good ways and bad ways to do GitOps. So for D, we've got Freddie Krauts, if anybody knows him, got involved. Talks about supply chain security and a whole other. This is from as recently as 2024. A whole other area. I could say it basically just says S-bombs are good, but obviously there's so much more nuance in that, and Freddie's done a bunch of amazing work, and there's a whole load of tooling and startups in that space as well. But these, all good things to think about. And then there's a 207 series. So this calls out zero trust architecture. 207 naked is maybe a sort of introduction to zero trust architecture, and then 207A, which again my colleague Zach was involved with. This is where it introduces the idea of identity-based segregation, right? So that we no longer segregating workloads by their network location, right? It's not network-based segregation. It's not, oh, you're on the same subnet as me, you're on the same side as the firewall, so I trust you. This basically says, right, if we take that 204B with the zero trust and we can add end user auth on the end, then we've got the sort of 5 pillars of modern zero trust, right? We've got encryption in transit, we've got service authentication, service authorization, end user authentication, and end user authorization. And we can pull all of those things together, and we can now define a trust boundary based on identity, because we strongly know what the workload is that's talking to us and on behalf of what human. And we can now flip from a network location, you're on the same subnet as me, so I trust you, to, oh, you've got the identity that I trust. And we can then shrink that boundary all the way down to an individual instance, to an individual pod. And that's when you get zero trust, because you've got to assume that the attacker's in the network. You've got to assume that anything outside of your pod is compromised, right? And therefore should be, zero implicit trust, should be trusted as little as possible, and it should prove that you should trust it by bringing authentication tokens. As a litmus test, could I do beyond call? Could I take all my applications, could I take all of my pods and give them all public IP addresses and put the whole thing on the internet, right? And if you're scared, of course you shouldn't do that, defense in depth and whatever, but if you're scared, then ask yourself why. If you've got any...
it's a blast from the past. Obviously, the Beyond Core journey for Google was, I think, 2011. They found that their unencrypted backplane cross-data center backbones were intercepted by China. I've said China in everything I've spoken about today. It is not a national sentiment. It is just a realistic one. And they decided that, well, first of all, we also had Snowden coming out sort of after that time. Maybe it was even before that. And we realized, okay, well, we can't just trust nation states anywhere to have the best interests of their citizens at heart. But Google said, well, actually, as somewhere that believes very much in the right of the individual, and this was pre-renouncement of doing evil, let's say, then they said, right, we now need to encrypt everything. All right, well, it makes sense. The cost of encryption on the network was coming down all the time. Middleware termination, well, edge termination boxes were becoming a lot faster. We were able to do this in software now. So they rolled out this Beyond Core zero trust concept, which by definition said you can give every single desktop and mobile device a public IP and rely upon metadata about the connection. What's the time of day? What's the identity with the connection? What's the source IP? Does it match where you think it's from? And various other metadata relevant to whatever subsystem within Google was the example they would give. And so I went and asked some of our friends at Google over the years, like, really? Did you guys put all of your all your infrastructure public? Like, no. It was just conceptual to get to that end point of like, why would you not do it? Okay, well, defense in depth, well, we actually want a perimeter around these things, because then we can say, if there's a 0 day on the host, there was a TCP/IP net filter 0 day a couple of years ago. Yeah. So that would be a zero-click style attack for desktop hardware. So of course, you still have a perimeter. You're still running an open VPN or a WireGuard or whatever form you want to get into the network. You still step up through different classifications, but the whole concept of that aggressive decentralization and sort of publicity of network is now what is ingrained in zero trust architectures. It's exactly the same thing when you get to Istio. of course, because with Istio, you've got layer 7 authentication, authorization, you know the workload that you're talking to, and you can perform intelligent traffic-based routing because you've then got a proxy that terminates that but can actually move the connection somewhere else. All these incredible features. Do you run a flat network? Well, no, you still run network policy around that. So from a TCP perspective, you can't layer 4 to anywhere on your cluster. You can't go and hit the API server just for the sake of it. You're still layering those controls because, as you say, defense in depth, 0 days will always occur. We're dealing with monoliths, the Linux kernel in an antiquated language. There will always be 0 days in everything. And so just premeditating what's the blast radius, if we assume compromise, how do we architect this system, is the beyond core mindset that's really made so much of an impact. And all the way back to this, and all the FedRAMP pieces, and where people really care about the potential breach and impact of loss of that data.
Yeah. What is a sidecar if not an identity-aware proxy? And that's a good way of looking at it, I guess, zero trust, right? Like you don't trust any other service, but you also don't trust your security mechanisms because they could have ODay in them. So let's just have lots, I guess. It's maybe a good way of talking about defense in depth that I hadn't thought of before. Cool.
Minimum viable, yeah.
Well, yeah, exactly. We're nearly out of time. It was 207 no letter, which was mandated by that executive order. Theoretically, every part of the US federal government should have submitted an architecture that implements the principles of 207, and they must be working towards actually building it. Now, whether that EO gets repealed or how far along folks are is a different question that we probably won't get into, but that's theoretical. And like Andy says, to see an executive order talk about the whole federal government, because they spend so much money, they have so many employees, so many different folks even in small little startups probably in this room supply them. There's actually a real impact, and when they want to do something like that, they go reference one of these NIST SPs to get it done.
And just to that point, one of the illustrious authors we've seen on one of these papers was working somewhere in the US where they were able to architect a system where all external integrations with their health, personal related data by external suppliers went through zero trust mechanisms, which immediately, even in the event of a 0 day or a second order issue, the capability of a team to have put those systems in place in the first place is such a dramatic increase in confidence in the general security culture of the organization. It's the same thing as shipping an SBOM. It doesn't really mean too much, but if a team is thinking about those things, then the house is probably in order in multiple different dimensions. And so just having those spider out from the federal government through into suppliers to the government, into the military, and then you're looking at healthcare and supplies into healthcare. So we hope that this will continue to sort of self-propel. Time will tell over the next few years, of course.
Yeah, cool. And one last slide, because I'd be remiss if I didn't do it. So there was one last SP that's probably relevant to this kind of cloud-native stuff, 800.233, co-authored by Muli, my colleague Zach, and our friend and Andy's colleague James Callahan, who would have been on this panel, but he's in Costa Rica. So
very happily so.
Yeah, hey JC. But no, so those folks were involved in this, which basically looks at the different ways. So a service mesh is there's not just one implementation of a service mesh now. If you're in this space, you'll know there's the sidecar mode, there's ambient mesh, there's the sort of Cilium model with node-based agents, there's entire meshes in BPF. There's several ways of actually the concept of a service mesh or of a sort of secure zero trust layer 7 network can actually be implemented in lots of different ways. So this SP actually just goes through in technical detail, with sort of threat models and stuff, and compares all of them and says, right, step back. What are you trying to achieve? Well, you're probably trying to achieve the control set out in 53, the kind of zero trust architecture, identity-based segmentation talked about in 204, 207. Step back and remember that's what you're actually trying to do. These implementations have trade-offs in terms of operational simplicity and resource usage or whatever, but let's look at what security properties they provide you so you can make an informed decision about which mode you want to run in. It may sound sort of very down in the nuts and bolts, but I think it's a good thing for folks to think about because it is an important decision when you're building a system. So yeah, these folks went and did some theory and then some practical threat models around that. And with that, I think we're out of time, but thank you, Andy.
Thank you, Matt.
I hope that was useful.